Hi Math 2 students, this is video 3 in our study of cubic functions and their transformations. And what you will notice is we are beginning here with the cubic function, and we're doing something that you are probably starting to recognize as a vertical shift. So we're going to plot our parent cubic function, and then we're going to go ahead and do a vertical shift of that parent function by adding 3 to all the y values. So let's begin by graphing the parent. And again, I can plug in xy values if I don't remember them, but I do remember that 1 cubed is 1, and 2 cubed is 8, and negative 1 to the third power is negative 1, and negative 2 to the third power is negative 8. And so we have our parent graphed here nicely. So now what we want to do is we basically want to shift our parent up 3 units. So to every y value that we have graphed, we're going to count up 3 units. So this is 0, 0, and it now becomes 0, 3. This was 1, 1, and it now becomes 1, 4. This was 2, 8, and so if I add 3, it becomes 2, 11. So that's just off our graph. 1, negative 1 shifted up 1, 2, 3. Ends up being, negative 1, negative 1. Ends up being at negative 1, positive 2. And this point right here at negative 2, negative 8 goes up 3 as well. It ends up being at negative 2, negative 5. And so if we connect our dots, we can see that we have taken our cubic function and shifted it up 3. So in our transformation, we would call that a vertical shift, and it went up 3. Our domain is all real numbers, and our range is all real numbers. But our x and y intercepts have changed, haven't they? If you'll notice, my y-intercept is at 0, 3. And it's not at all clear to me by looking at the accuracy that I graphed this that I can tell what the x-intercept is. So we have a little rule that says in order to find the x-intercept, we would plug in 0 for y. So this would be 0 is equal to x to the third plus 3. I would subtract 3 from both sides and get negative 3 equals x to the third. And so my x-intercept is at the third root of negative 3. Now keep in mind I can't take square roots of negative numbers, but I sure can take cube roots of negative numbers. And if I wanted to approximate this, I would use my calculator. And what I would do with my calculator is, I don't know that you can see this. Let me see if I can get it focused in a little better. What I would do with my calculator is I would take negative 3. Notice I'm using parentheses. Well, that's just not showing up very well at all. So I would take negative 3 and I would raise it to the 1/3 power. And that gives me approximately negative 1.4. And I would need to approximate it in order to graph it, because I don't know intuitively where the cube root of negative 3 is on this graph, but I sure can find negative 1.4. And if you look at what we've drawn here, it looks like we're going through negative 2, but we're actually just a little bit off. And that graph should look more like that. So that's it for shifting a cubic up 3. Let's take a look at the example 3. And in this example, we're shifting a cubic down 5. So again, we're going to plot our parent function. And by now, you should feel comfortable plotting these 5 points. You should know where they came from in the parent graph. And if you don't remember them off the top of your head, you should be able to insert values for x and get values out for y. So let's take everything and slide it down 5 units. 0, 0 becomes 0, negative 5. 1, 1 becomes 1, negative 4. 2, 8 becomes 2, and let's just go down 5. 1, 2, 3, 4, 5. And I land at 2, 3. So that's this part of our graph. Now, negative 1 goes down 5 and ends up here at negative 1, 6. And negative 2, negative 8 is going to end up shifting off our graph. That's going to be kind of hard to graph. So let's look at our transformation. We went down 5, which is a vertical shift. Our domain still is all real numbers, and range is all real numbers, and basically for all the cubic functions it will be. Our x-intercept no longer is at 0, 0, nor is our y-intercept. And if we look at our graph, we can see our y-intercept at 0, negative 5. But again, to find our x-intercept, we're going to have to do a little algebra. 0 is equal to x to the third minus 5. So I'm going to add 5 to both sides of this equation and get 5 is equal to x to the third. And then I'm going to take the third root of both sides. So the cube root of 5 is where my x-intercept is. And I could write that like the cube root of 5, comma, 0. And that would be how I would answer this question if I wanted an exact answer. If I wanted to approximate the cube root of 5, I would have to take 5 to the 1/3 power in my calculator, and I would get approximately 1.7, 0. So if you look at our graph, it looks like we're kind of going through 2. We're just a little bit off in terms of where our graph is going. And we could make that adjustment and redraw our line. So in the last example, we're combining a shift up with a reflection. So let's take a look at what that looks like. We always start by graphing the parent every single time. So here is our parent graph. And again, you should be comfortable graphing these points. If not, you can substitute them into the parent equation. Y is equal to x to the third. And you can see what y values come out. So first I'm going to do my reflection. Order of operations says I'm going to multiply by negative 1 before I add my 2. So I'm going to reflect over the x-axis. What was at 1, 1 is now at 1, negative 1. And now I'm going to shift up 2. And that point lands right on top of itself. This point I'm going to reflect over. And when I reflect, I can't really reflect 0 over itself. So the reflection does nothing to the point 0, 0. But then I shift it up 2. I'm going to reflect the point at 1, negative 1, negative 1. So there's my reflection at negative 1, 1. And then let's go up 2. So what you see is my graph beginning to take on the shape of the reflection. When I reflect negative 2, negative 8, it ends up at negative 2, 8. And then I shift up 2. So I have a point here. So I'm going to want to make my graph continue on through that point. And then let's reflect 2, 8 over. It ends up at 2, negative 8, and then it has to shift up 2. So in this example, not only did I reflect over the x-axis, but I also shifted up 2. There's the signal that I reflected, and there's the signal that I shifted up 2. Our transformation is a reflection across the x-axis and a vertical shift up 2. My domain is all real numbers. My range is all real numbers. And now let's take a look at my y-intercept is really easy to find at 0, 2. My x-intercept I'm going to have to solve for. So I end up getting y is equal to negative x to the third plus 2. I'm going to subtract 2 from both sides of this equation. Oh, that has to be 0 if I'm finding the x-intercept. So I'm going to subtract 2 from this equation, negative x to the third. Then I'm going to multiply both sides by negative 1. 2 is equal to x to the third. And then let's take the third root of 2, and that's what x is equal to. So my x-intercept is at the third root of 2, comma, 0. Now, admittedly, if I wanted to graph this, I would have to approximate the third root of 2, which would mean taking 2 to the 1/2 power at my calculator. And I would find that this is approximately 1.3. And so I would know where to graph it on my coordinate plane based on the approximation of 1.3. So those are your vertical transformations of cubic functions.